In this video, I want to talk about 4 annuity symbols. The first symbol is present value of any annuity immediate. You don't need to worry about why it's called immediate. That will be clear later. So this is the present value of any annuity immediate. The second symbol has a dot, two dot symbol. This is present value of any annuity due. And the third symbol is the cumulative value of any annuity immediate. The last symbol is cumulative value of any annuity due. And these symbols look odd to you right now, but gradually as you work through in a problem, these symbols and their formulas will become a second nature to you. And before we look through these symbols, let's go through this common example to see what we are up against. And suppose, let's go through a financing example. Suppose you bought a house, say 250K thousand house, and you can pay it over say 30-year mortgage here, and 30-year mortgage is the most common time frame for mortgage financing. You could have 10-year, common is 10, 20, or 30, or 15, or 25. What's 30 years most common here? So basically you buy a $250K thousand house. You can pay it over 30 years, which is the 360 months. So this is say month 1 and month 2, month 3, all the way to month 360. This is 359. So you have level payments because this is your X, level payment. Suppose your annual interest rate is J. So your monthly interest rate is the 1 plus I is monthly, raised to the 12th power equals J, is equals 1 plus J. So your I equals the 1 plus J to the 1 to 12th power minus 1. So by solving the equation, we'll say 250K is your X, your first payment X, discounting to time 0. So this is XV, V the discounting factor, right? The second payment discounting back to 0, so XV squared. The third payment discounting to time 0, X to V to the cube, plus all the way to X to V 359 plus X to V 360. The V is the 1 divided the I. I is the monthly effective interest rate. Now we get X equals the 250 divided by V plus V squared plus V cube, all the way to sum up to V360. Okay, and this situation happens quite often, right? You suppose you are a bank. You give out mortgage loans to people who are going to buy the house. You're going to run through a lot of this sort of calculations here. One day you're probably going to be tired. You say, why don't I invent something to call this denominator, right? So that way, whenever somebody comes here to ask for a loan, I can just plug in this formula already set up to calculate the monthly payment, level monthly payment of X. Okay, somebody said, well, why don't we invent this thing? The denominator is called something. This is A annuity present value 360. We have 360 payments. Then the interest rate is I. So now your X becomes very simple. X is 250K thousand divided by A 360. Okay, so that way you can actually create some tables here. You can vary your A by the pair. Your general formula is ANI. Okay, you can already set up your calculate your A, your present value of serious monthly payment or level payments over a period of time, a different interest rate, a different number of years, you already set up ready for you when somebody come here to borrow money. So you already have a formula to account for it. You already have a symbol to account for it. That's why the symbol is invented. Now let's derive this formula for present value of annuity annuity immediate. Immediate meaning that your payment is made right after your loan is borrowed. So typically means 1 period after your loan is borrowed. So basically you have this your payment, this is time 0, this is time 1. You pay $1, we just say $1. Year 2 you pay $1. Okay, this all the way pattern continues. So time n-1 you pay your $1, and then time n you pay your final $1. So my question is, what is the value of this series of payments at time 0 here? Okay, and so this is your AM. Here's the V, we explained earlier, V squared, V cubed, all the way to V to nth power. This is a geometric progression series. So the sum equals the first term minus term after the last. Your last term is Vn. So your term after last is V to n plus 1's power, divided by 1 minus the common ratio V. So take the factor out of the V. So basically V times 1 minus V to n's power divided by 1 minus V. And your V is the 1 plus I, right? 1 divided by 1 plus I, that's your V. So all I'm going to do is to take the numerator and denominator, multiply both by 1 plus I. So the numerator becomes 1 minus V to n's power. The denominator becomes I. So this is the formula. This is n-year annuity immediate, the present value. And the one thing I want to tell you that is although it's common for us to write this time 0 here, your first payment 1, we could write anything. For example, you could have this, your first payment could occur at time 5. Doesn't matter. The time 5 times this time 5, you pay $1. Time 6, you pay $1. All the way continues. So you could pay it as time 9, you pay $1. Time 10, you pay $1. Okay, this is time 4. So in this case, it's still here. Okay, because this is still, if you discount all these payments to time 4, 1 period before your first payment, we count A. How many payments we have? We have 6 payments. So A6. This is your interest rate is I, discounting to time 4. Okay. My point is that you don't need necessarily here have to be time 1. Your first payment can occur at any time, not necessarily time 1. Whenever you discount these series of payments to the 1 period before your first payment, you get this symbol. Okay, you get this AN symbol. Not necessarily have to be a payment has to be occurring. The first payment have to occur at time 1. Does not matter.